relevant. Okay. Okay, well, we had this quiz here. We want to find the equation of tangent plane for this function at the point 114. And then you want to find the z-coordinate of the tangent plane for given x and y and compare to the function value at that same x and y value. Okay. Now, the whole principle here is that the tangent plane the normal vector is a cross product of two tangent vectors. That's where you start, not with a formula. You start with a cross product of two tangent vectors. Okay. Now I understand because there are only 2 days between the assignment and when it's due, how with limited time you grab a formula. Okay. But you want to move well beyond the formula and also think about the way it was developed. Quick aside, how many of you looked at some of the AI summaries? Okay. How useful do you find them on a 1 to 5 scale? Okay. Think about how they could be more useful. I think I put up about 5 of them on the last assignment. Okay. Yeah, I didn't expect you to read through all 5 of them, but you might look at some of the alternatives. Sometimes it's a little more detailed, sometimes it's a little more compact. Sometimes it talks about concepts, sometimes it talks about formula. Okay. What is useful to you? So if you get a chance, look at those. If you don't get a chance, I know you got plenty of things to do. Okay. So no prejudice, but we're trying to figure out how to give you something that's useful to you and something will be useful to you in preparing for a test. And there will be a test. Somebody, I think I said something about it being this week. And then weather intervened and of course it didn't affect this class, but I realized that I want to have the test that goes up through section 4.5, okay, which won't be due until Tuesday. So it doesn't make sense to have the test before then. And then, of course, week after next is spring break week. So my plan is put the test in the testing center on Wednesday next week. It'll be due on Wednesday, by Wednesday of the week you come back. Okay, take it before or after. Get it out of the way so you enjoy spring break or do something else. Okay, or spend the time preparing, whatever it takes. So that will be the plan. Everybody understand that? I'll put it in the assignments page for today. Okay, so again, you want the tangent plane. Tangent plane occurs. First thing you do is get the normal vector, which is cross product of two tangent vectors. Now, tangent vectors are I plus fxk, j plus fyk. You need to understand why that's so. To have good mastery of the material, to get concepts that you're going to have to build on throughout the rest of the course. Okay. We illustrated that. We went over it in detail. Look back at the video, look at the AI summary. And if you don't understand where that comes from, well, you got to think about it a few times. A couple of days is insufficient time to really think about it. Of course, I think I talked about that first week ago. Um, so that's your key idea. We're talking about derivatives of functions of multiple variables. Okay, you use the derivatives not in a formula with f of x naught, y naught, and all that stuff. Okay, you think about, or if you use the formula, think about why the formula is what it is so you remember it correctly. Okay, so that the normal vector is the cross product I cross j is k. I cross k is negative j. J cross k is negative I. That's normal. I just don't like the way that sentence is, that statement is coming up. Um, Vector in the plane is going to be x minus 1 I plus y minus 1 j plus z minus 4 k. And make sure you understand why that's so. 114 is a point in the plane. If you move from 114 to xyz, you move along this vector. That's a vector in the plane. This is perpendicular to the normal vector. So negative fxi minus fyj plus k dotted with x minus 1I plus y minus 1j plus z minus 4k equals 0. I wrote that kind of small, but we did that in detail. We're just saying that because of the derivatives and the geometry of everything, these vectors are tangent to the plane. Normal vector is our cross product, which is easy to calculate if you got the two vectors. A vector in the plane has this form, a vector from 114 to xyz. There it is. Make sure you understand why the vector from 114 to xyz is what I wrote. And then it's perpendicular to the normal, so if you take the dot product of the normal and that vector, you're going to get 0. So negative fx times x minus 1 minus fy times y minus 1 plus c minus 4 equals 0. Fill in the details. What do you need to complete this? You just need the value of fx and the value of fy, right? Well, fx is really easy. It's 2x. Fy is really easy. It's 4y plus 1. Yeah, I think everybody got that. I think most everybody has partial derivative stuff. And then you plug in x equals 1, y equals 1, and you get fx and fy. So I'm not going to take valuable class time to calculate fx and fy. Uh, at 1, 1, fx equals 2x equals 2. Fy equals 4y plus 1 equals 5. Right? Check me, make sure I write things down quickly. Think more about what I'm saying and what I'm doing. Okay? So the tangent plane is minus 2 times x minus 1 minus 5 times y minus 1 plus z minus 4 equals 0. So that's minus 2x minus 5y plus z equals, well, that's going to be 2, and that's going to be 5, so that makes 7, and minus 4 makes. Now, at that point, we can visualize the plane even. We could make the graph, and this is kind of off to the side. It's not part of what I ask you to do, but since, what's the x-intercept? It's at x equals 2. If y and z are 0, you get negative 2x equals 4. So you get x equals 2. There's the line x equals 2. If x and z are 0, well, y is going to be 4/5. And z, well, it's going to be 4. So maybe you're up here pretty far. And you can draw a little triangle, which is in this plane. I haven't done that before, so I decided to go ahead and do this. Okay. That gives you an idea how the plane is oriented. And you can see if it even makes sense in terms of that paraboloid. Of course, you got to graph the paraboloid and think about how the paraboloid intersects the YZ plane and the XZ plane and all that stuff. So you can do all that, and it's worth doing. It's not what I ask you to do, but if you're working on this problem, you want to be proactive about it. You think about those things. Now, given the rigors of your curriculum, jobs, life, whatever, maybe time to think about it, maybe you don't. So that's up to you. But I do recommend that you develop as much depth of understanding as you can in this course as possible, because it's the language of most engineering. Okay. Anyhow, there's the equation of the tangent plane. And of course, that gives you z equals 4 plus 2x plus 5y, if I'm not mistaken. We got that? Yeah. At xy equals 0.7, 1.2, the arithmetic is straightforward. 2x is going to be 1.4, 5y is going to be 6, that's going to be 10, and 1.4. I think z equals 11.4. It's 1.4, that's 6. Um, yeah, I'm really getting 5-1. Okay. Not sure that makes sense. I might have a mistake in there somewhere. So you probably want to work this yourself and make sure it makes sense. Um, just looking at things. Fy is 5, fx is 2, straightforward, cross product. Got to have fy times j and fy times I. I think I said fy is 4, fy is 5. Um, I have a sign wrong there or something. I did do arithmetic wrong here. I got 2 from this. I got 6 from this. It should be, oh, gee. How did I get 4? I get 2, I got 7. You get a -2 and a -5 is -6 plus 4. That should be -2 instead of 4. And this picture isn't quite right because I did my arithmetic wrong over here. Just a -2 times -1 is 2. -5 times -1 is 5. 2 and 5 make 7. I subtract 7 from both sides and then add 4. Actually, I'll get it right. Should be -3 maybe. And if it's -3, then again, my 2x is 1.4, my 5y is 6. I get 6. 7.4 minus 3 is 4.3. Okay. It could not have been 11 because it has to be pretty close to this because 0.7, 1.2 is pretty close to 1, 1, right? And the partial derivatives are not that extreme, so it couldn't have been off by that much. Among other things, if you have the ability to visualize what's going on, you can do things like spot that there's something egregiously wrong at this point and debug it, right? And you got to do a lot of debugging. Okay. Now, I'm not even completely sure about that, but at least it makes sense. In my arithmetic, I don't know. Okay. The actual value of this function is what? It's y, which is 1.2 plus x squared, which is 0.49 plus 2y squared, which is 2 times 1.44, which is 2.88. Okay, now 2.88 and 1.2 is convenient, 4.08, and then I add 0.49 and I get 4.57. And that's probably wrong too. But you see, it's pretty close to this, right? Well, what's a differential? Differential is dy plus 2x dx plus 4y dy, which 4y plus 1 dy plus 2x dx. Dx is negative 0.3, dy is 0.2. So df equals 4y plus 1. Now you're basing this differential on the point 114. X is 1, y is 1. So I guess the differential is 5 dy plus 2 dx evaluated at 1, 1. Now I'm outlining this. If you don't understand it, review the differential so you can bring it into compliance, bring it into the same conceptual framework as you have for the rest of it, okay? So df equals 5 times negative 0.3 plus 2 times 0.2 negative 1.1, which makes no sense at all. Clerical error after clerical error. No, it was right. But okay, it's 5 times, I got my dx and dy confused here. 5 times 0.2 plus 2 times negative 0.3. And that's 1 minus 0.6. Which is 0.4. I got 4.3 here. I probably should have gotten 4.4 because your df is 0.4. Okay. And I don't want to go too far with this, but that's 1.4 and 6 is 7.4 and 7.4 minus 3. 7.4 minus 3, it is 4.4. Okay. The point is your differential tells you how much the tangent line or tangent plane approximation is going to differ from your value at your x naught y naught 0.11. Okay. Working out the tangent plane and fixing the mistakes, we found the tangent plane predicts 4.4. Working out the differential and correcting the mistakes, we found out that the differential is 0.4. Now, first we found that this is 4.3, but the differential is 4.4. We said, we got to debug the differential or we got to debug this. So I did this calculation again, and 7.4 minus 3, there are a lot of 4s and 3s floating around. I wrote 0.3, what should have written 0.4. Okay? Which means you should never trust my arithmetic. Sometimes it's pretty good, but it's always uncertain. Okay. Uh, and of course, you shouldn't trust your arithmetic either, but you should do it. You should at least estimate it before you plug it into your machine. Otherwise, you don't develop the brain connections to be able to work with AI productively. Or you develop fewer brain connections. Maybe you develop really good brain connections in a different direction. Okay. I recommend you develop all the brain connections you can because I think you're going to need them. You got finite time. I don't expect miracles. Just semi-miracles will be sufficient. Do the best you can. Um, there's a full circle here and demonstrations of how you can debug things when you do stupid things, because you're always going to do stupid things. Maybe not as stupid as mine, but you're going to do them. Okay. Okay. So with my last comment, which is here's what's going on. The formula summarizes it. If you don't know what's going on and just use the formula, you're not going to understand what's going on. Okay. You still have something. It's not insignificant to be able to use the formula. You probably pass the course using the formula. You're probably not going to have all the connections to do as well as you could. Again, there's finite time. Do the best you can with what you got. Okay, now we want to talk about partial, about the chain rule. There is one formulation of the chain rule. The other one is dy dx equals dy dz dz dx or whatever. Okay, dy dt dt dx or dy dx or dx dt. You know, you can use the chain of those fractional expressions, which aren't really fractions. And when we talk about derivatives of multivariable functions, we want to use that chain notation, the dy dx's and dy dt's and stuff like that. But we're also going to use primes. You need to understand what this means. And what this means is a change in x drives a change in g of x at rate g prime of x. You really want to understand that statement, and you really need to ponder it. which in turn drives the change in F, because if G of X is changing at rate G prime of X, then a change in X causes a change G prime of X times the change in X in this, which is what drives then the change in F. So the value of F is determined by the value of G of X. The rate at which F changes is driven by both the rate at which G changes and the rate at which F changes. Okay? So it's the rate of change of G at X multiplied by the rate of change of F at G of X. Okay, well, try to keep that idea in mind, but you really need to ponder it. Now, consider f of x, y where x is a function of some parameter t and y is a function of some parameter t. Okay? Then what is df dt? Well, df dt is change in f divided by change in t, right? Well, df dt approximately equals a change in f over the change in t. The change in f due to the change in t. That's written small and Slavic, but it says change in f due to change in t. You divide that by the change in t and you get the rate of change of f with respect to t. So t changes a bit, causing x to change and y to change. Each of which causes f to change. Again, you should thoroughly understand that. Now, whether you can do all the manipulations of the proof, this thing, and they aren't that bad, the book will show you. What I really want you to see is the concept, and then do your best to understand the way it's proved in the book. I might write out the proof, I might not. I'm going to give you the conceptual idea that all you got to do is put it into notation and you've got the proof. Okay? If I give you a proof, you're going to have an awful hard time connecting the proof to the concept. So I want to start with the concept. Now, some of you might, what I'm saying is a typical class, 90% of the class will understand it best by starting with a concept because they're going to have trouble understanding due to deficiencies in the curriculum all the way back to first grade. Okay. Uh, and you got to try to build that, but we're not going to expect you to have it appear full blown on short notice. You develop it as you go. Okay. Now, what am I going to do with these boards? Okay, well, we have that background. We have those ideas. So what I'm going to say is, a little more detail now. The f dt depends on the values of x of t and y of t. And on the rates at which x of t and y of t change. Now that follows directly from what I said here, except maybe it's implicit that if you know t, then you're going to know x and y, right? The value of t tells you what the value of x and y are. But the rates of change of x and y with respect to t tell you how quickly this thing is changing at those values of x and y. Well, I'm going to cut to the chase here. And this is df dt. It's not a partial derivative because it's with only respect to one variable. T is the only variable here. X and y are intermediate variables. Okay. Now, in a minute, we'll have x and y both being functions of u and v. It gets a little more complicated when you draw a T diagram and tree diagram to understand it, which I've never really done. I let the book do it. But I like the idea of the tree diagram. Um, so we'll talk about it. Okay, df dt then equals partial of f with respect to x times dx dt, which is the rate at which a change in t drives a change in x, times the rate at which that change in x causes f to change. Okay? So dx dt is, I like to say it this way, I don't know if it's good, bad, or indifferent, but it's the rate at which a change in t drives a change in delta x due to the function x of t. Okay? That's this part. This is I'm writing fast. It's hard to read and it's small. It'll be there on the video if you want to see it a little more clearly. You're always welcome to use a zoom camera to take a picture of it. But it'll be right there. The AI summary gives you a timeline, so you can kind of quickly look at the AI summary, say, okay, I need to go to somewhere between minute 4:38 and minute 5:02 on the video. So if I look there, I'm probably going to see it. Okay. So again, dx dt is the rate at which delta t drives a change in x. And df dx is the rate at which a change in x in turn drives a change in f. Okay? You multiply those two together and you get the rate at which t drives a change in f. But it's not the total rate at which a delta t drives delta f. It's the rate at which a delta t the change in t drives a change in f due to x. Okay? So the delta t makes x change, and that change makes f change. Okay? However, a change in t also makes y change, and f is a function of x and y, right? So you have the same term, and I'm not going to write out all the details, but you ought to think about what they are so you can kind of focus on what they mean. This is dy. So what's this? dy dt is the rate at which that change in t makes y change, which in turn makes f change. Okay? Now that's what the chain rule is telling you. It's not a formula that you imitate mindlessly, although, it is at first. You learn to calculate it, and then as you calculate it, you keep thinking about what it means until it finally dawns on you what's really going on here. And then you have a really good grasp, and you understand everything else that follows better than you otherwise would. Okay? If you try to put this course together with a bunch of formulas, you're only going to be partially successful. If you do it rigorously and carefully, you'd be successful enough to at least pass the course with a half decent grade, okay? And you'll have a tool that you can use, but not as good as the tool you can use if you understand conceptually what's going on, which is what I do. Okay. So there is the chain rule. I haven't proved it in terms of epsilons and deltas and all that stuff. That's not that hard to do if you're good with the symbols. And if you understand the concept, then what's going on with the symbols makes sense. Okay. Debating about whether to look at a tree diagram right now or not, but I think not. All right, now I can expand this a little bit. In the first place, if f is a function of three variables, x, y, and z, it should be obvious that you'd have a partial f with respect to z times dz dt, right? Okay? If you got 48 variables, x1, x2, x2, x up to x48, you'd have partial of f with respect to x46 times the partial of x46 with respect to t. You'd have any number of them. And, you get into data science and stuff like that, and you're probably not on that track, but who knows where you're going to end up. Okay. Uh, you will do some data analysis in an engineering curriculum, and if it really turns you on, you might end up undergraduate school data analysis and saving us all. Okay. Uh, you deal with vector spaces with millions of variables that might be driven by one variable. You'd have a partial of this whole thing with respect to t, but it'd have 10 million parts. And you're not going to do those by hand, but you need to write these out by hand so you understand what those are doing, right? Okay. Okay, well, I'm preaching a little bit. There are other ways to look at these things too. Listen to other people that know what they're doing. Some of them, most of them probably know more than I do, so especially ones in counter tech. But your engineering professor here knows a lot of stuff too. So listen to him at least as much as you listen to me. Okay. I'm just going to write out the chain rule. If you've got f of x, y, x equals x of u and v a function y of u and v. Okay. Now again, u and v are going to change a little bit, right? So we got to start with what the effect of a change in u is and what the effect of a change in v is. It's x of uv, y of uv. Okay, so we have you're gonna pick that up because I'm going to use u and v a lot. Okay. What's the effect of a change in u? Answer. Changes x. At a rate that's the partial of f with respect to u. It's not dx, or dx du, it's partial of f with respect to u, because now x is a function of two variables. Whereas previously we had x and y as functions of just one variable, okay? It changes x at this rate, changes y. The rate partial of y with respect to u, okay? That makes sense? Okay, I'm going to write that again a little bit later because structure it. The effect of delta u, it changes x at a rate dx du, which changes x, which changes f at the rate df dx. Okay? Not just df dx times or partial f with respect to x times partial of f with respect to u. Changes y at the rate partial of y with respect to u, because we're looking at the effect of the delta u. That changes f at the rate partial f with respect to y times partial of y with respect to u. Okay? The change in f due to a change delta u is partial f with respect to x plus partial f with respect to u times delta u. Okay, so u changes by a little bit, right? It changes x by, at the rate, partial f with respect to u. And if the change in u is delta u, the change is partial f with respect to u times delta u. In other words, if the rate of change with respect to u is 5 and u changes by 0.03, how much is x change due to that? 5 times 0.03, right? Rate of change times the change in u. I'm not going to write that down, waving my hands over it, but it's an important idea. We'll try to illustrate it with numbers, but I'm not sure. We're not doing that great with time, so maybe let you ponder a little bit. Okay. Um, okay. So the change due to delta U is the change in X, which is partial of F with respect to U times delta U, times the rate at which F changes with respect to X. I do want to try to do a numerical thing there. Well, it doesn't change just because of X changing with respect to U. It also changes because Y changes with respect to U. So it's partial of F with respect to Y times the partial of Y with respect to U, delta U. For example, I'll do numbers. If partial F with respect to U is 5 and partial Y with respect to U is -3, and delta U is 0.02, then the change in X is 5 times 0.02. Change in Y is -3 times 0.02. Now let's say partial of f with respect to x is negative 2. Partial of f with respect to y is plus 4. Then the rate of change of f due to the change in x is negative 2 times the change in x. What's negative 2 times the change in x? Well, the change in x is 5 times the change in u. So this change is 0.1, and f changes at rate negative 2 with respect to x. So the change is negative 2 times 0.1 and so forth. I'm going to let you go on with that partially because I'm out of space and partially because we need to develop a bigger picture, okay? But see if you can reason this out from those numbers. And if you got a question on it, email me. I might even put a little append on this class to do that with the numbers. But we need to get the bigger picture. So this is the rate of change of f with respect to u. Okay? So partial f with respect to u is just this whole thing. And you multiply that by delta u, and you get the amount of change in f due to that little change in delta u, or the approximate amount. Okay? The change in f due to a delta v is the partial of f with respect to x times dx dv, the rate at which v causes x to change. V causes x to change at this rate, which in turn causes f to change at this rate. The rate of change of f with respect to u is this, or it's this. Rate of change of f with respect to v could be written this way, or expanded this way. Again, change u a little bit, you change v a little bit. Just like we changed 1, 1 over to 0.7, 1.2 in the quiz problem, right? So there we changed X by negative 0.3, we changed Y by plus 0.2, right? You get a little change in U, a little change in V. Now, if it's a finite change, since the derivatives are constantly changing, you're not going to get the exact result, but it's going to be an approximate result, okay? And the rate of change of F with respect to U and the rate of change of F with respect to V, these are exact if you're given a value of U and V, okay? Give me the values of U and V, and it'll tell you exactly what the rate of change at that set of values U and V is. Change U and V a little bit. The rates have changed just a little bit. But if you don't change U and V by much, you get a good approximation. That's what's really going on here. Now, there are more complex expressions. You can go blind, so you'll know. After I'd finished 4 semesters of calculus, I was going on with physics, which I stopped going on with a couple of years later and went into math. I took an advanced calculus course. It had these big long things, chain rules, but even a little more expanded than this. I went blind. I couldn't figure it out until I stopped and worked it out myself. I couldn't, I just don't look at formulas that way and see what's going on until I delved into it deeply. Some people see the formulas right away and then use that to delve into it. All I'm saying is you're going to see formulas in your books that maybe look a little confusing, but if you understand this, and what we did over here, there's a pattern to it. It's simple. The book shows you tree diagrams. I was going to do that, but we're out of time. Okay. And the tree diagrams are pretty obvious if you understand this. But of course, the tree diagrams can help you make this more obvious. So work on it as you will. Okay. So, want to be up through 4 or 5 by Tuesday. Think a little bit more about those tangent planes to the extent that you have time to do it. Okay. You really want to be able to do that based on 2 tangent lines.